model universe. Cloud and rain model is the combination model of Big Bang theory and steady-state theory. Cloud and rain model adopts with improvement up-to-date observable universe of Big Bang model with its structure and dynamics, but have character like steady-state model that is cyclic universe. Until now, cloud and rain model only talks about structure of the universe. Cloud and rain model doesn't have concept of the origin of the universe yet. In cloud and rain model, the one universe has center or core. Contents of the mighty space are cloud of galaxies, dark matter as atmosphere of the space and voids. The cycle of events in space is the continuous construction of galaxies cloud and condensation of aged galaxies and crashed galaxies. The condensed galaxies or dead galaxies will flit toward universe's core like rain over our home. Dark matter, black hole, and CMB. What cloud and rain models state about black hole, dark matter, and CMB? Compressed matter. It is a great amount of matter packed into a very small area. Think of a star 10 times more massive than the sun squeezed into a sphere approximately the diameter of New York City. The result is a gravitational field so strong that nothing, not even light, can escape. Ref 16. Scientists cannot directly observe black holes with telescopes that detect X-rays, light, or other forms of electromagnetic radiation. Ref 16. Cloud and rain model treats everything with simple logic first as far as it is possible, but always refers to pattern facts of nature, like the way we get this model cloud and rain model. Referring to script about black hole above, cloud and rain model prefer to state that black hole is a compressed matter. Cloud and rain model states that compressed matter or compressed atom structure matter is the matter where atom nucleus and electrons become one, so that there is no space in that compressed matter. The matter is just dense matter. In the structure of ordinary matter, there is very much space between atom nucleus and electrons, or space more than 80% of volume in the structure atom, but it is different with compressed matter. In compressed matter, space almost or equals 0% and matter almost or equals 100%. So cosmos that contains space almost or equals 100% have no power to prevent compressed matter to flit faster than light. Unlike normal matter, dark matter doesn't interact with the electromagnetic force. This means it doesn't absorb, reflect, or emit light, making it extremely hard to spot. In fact, researchers have been able to infer the existence of dark matter only from the gravitational effect it seems to have on visible matter. Ref 8. Dark matter is a hypothetical form of matter thought to account for approximately 85% of the matter in the universe. Dark matter is called dark because it doesn't appear to interact with the electromagnetic field, which means it doesn't absorb, reflect, or emit electromagnetic radiation and is therefore difficult to detect. Various astrophysical observations, including gravitational effects, which cannot be explained by currently accepted theories of gravity unless more matter is present than can be seen, imply dark matter's presence. For this reason, most experts think that dark matter is abundant in the universe and has had a strong influence on its structure and evolution. Ref 9. However, at this point, there are still a few dark matter possibilities that are viable. Baryonic matter could still make up the dark matter if it were all tied up in brown dwarfs or in small, dense chunks of heavy elements. These possibilities are known as massive compact halo objects, or MACHOS. Ref 10. Black hole and dark matter have several the same characters, they both having gravitational effect and they both being the dense object. So, by pattern facts of nature and observing our local planet environment, where in ordinary matter we have molecule, or a small scale of ordinary matter, and observable matter like building, car, rock, mountain, as large scale of ordinary matter, we get that dark matter is also compressed matter, like black hole. Dark matter is the small scale of compressed matter and black hole is the large scale of compressed matter. In relation to its denseness, compressed matter has a very high gravity. Samples of compressed matter are dark matter, black hole, stars nucleus, planets nucleus, satellites nucleus, and universes nucleus, core. The expectation of compressed matter to exist in the center of satellite, planet and star is coming from the fact that the gravity of the center of the mentioned above should be ultimate strong so that every part of the satellite, planet, and the star won't rip apart. In the absence of any pressure, compressed matter is expected to exist at ultimate low temperature. For example, dark matter in space at temperature below 3 degrees Kelvin. By significant increasing temperature, it is expected that dark matter will convert into subatomic matter. The subatomic matter then will convert into ordinary matter. Nevertheless, compressed matter seems to exist also at higher temperature, in the condition of extreme high pressure, like at planets' nucleus, satellites' nucleus, and stars' nucleus. In this event, the ordinary matter that blankets the compressed matter gets ultimate strong gravity from compressed matter, so that the blanket doesn't break and keeps maintaining the high pressure, and the heat at blanket area of compressed matter prevents that ordinary matter to convert into compressed matter. Dark matter's role. Dark matter has several very significant roles in space. 1. Dark matter is the source of stars' construction and galaxies' growth. 2. Dark matter that fleet faster than light in space, drag galaxies away from universe's core. This event has been translated to be caused by the Big Bang 13.8 billion years ago. This dark matter's action is responsible for most cosmos object redshift and accelerating of receding cosmos object to increase with increasing the distance. This accelerating receding has been translated as dark energy in Big Bang theory. 3. The existence of dark matter's action in supercluster of galaxies helps the spread black holes and the stars to get there stationary on their orbits in supercluster of galaxies. 4. Dark matter fleets with the speed faster than light in space. Particles of dark matter will flit toward random directions, touch and collide with each other. We cannot see this dark matter dynamics. Nevertheless, this dark matter dynamics leaves microwave radiation everywhere in cosmos, which has been identified as cosmic microwave background radiation or CMB. The temperature of CMB is so cold, only about 3 degrees Kelvin, because dark matter flits in an emptiness of space. This way, cloud and rain model universe answers about cosmic microwave background. Dark matter and CMB are everywhere in space, but we have limit of observation that cause us get around 13.8 billion light years as limit of our observation. With more developed science and technology, we might get this observation limit farther. Dark matter is the atmosphere of the universe. The universe's structure has equality pattern with the model of the Earth, the cloud and the Earth's atmosphere. The universe has center or core. The observable universe which we get is just like the cloud of our Earth. Dark matter in space has equality pattern with atmosphere of the Earth. The location of the universe's core is the area where all superclusters of galaxies get attracted by dark flow toward it. Although superclusters of galaxies might get away to recede the universe's core due to pushing force of dark matter that act as atmosphere of the universe. So, dark matter which we have identified so far is naturally the atmosphere of the universe. Cosmic microwave background, CMB. You cannot see the CMB with your naked eye, but it is everywhere in the universe. It is invisible to humans because it is so cold, just 2.725 degrees above absolute zero, minus 459.67 degrees Fahrenheit, or minus 273.15 degrees Celsius. This means its radiation is most visible in the microwave part of the electromagnetic spectrum, Ref 17. Refer to dark matter's role number 4 above. We noted that CMB is the trace of dark matter's dynamics. Dark energy. The following is the script from NASA Science Dark Energy, Dark Matter, Ref 10. Faster than light. Compressed matter or compressed atom structure matter is the matter where atom nucleus and electrons become one, so that there is no space in that compressed matter. The matter is just dense matter. In the structure of ordinary matter, there is very much space between atom nucleus and electrons, or space more than 80% of volume in the structure atom, but it is different with compressed matter. In compressed matter, space almost or equals 0%, and matter almost or equals 100%. So, cosmos that contains space almost or equals 100% have no power to prevent compressed matter to flit faster than light. Einstein's special relativity equation is meant for space, time, and light. A thing must contain space and react with light in order to conveniently suit special relativity equation. An ordinary matter where it contains more than 80% volume of space and reacts with light is excellent for special relativity equation. Again, it is different with compressed matter. In compressed matter, space is almost or equals 0%, and compressed matter doesn't interact with light. As light does interact with ordinary matter, like to pass through and to bounce from ordinary matter. On the contrary, light doesn't pass through and bounce from compressed matter. And again, special relativity equation doesn't have power to limit the traveling speed of compressed matter. Although compressed matter disobeys upper speed limits settled by special relativity, but it still fully respects special relativity. Actually, some misinterpretation has occurred. The following is the text taken as it is from Wikipedia, Speed of Light. As a result, if something were traveling faster than c relative to an inertial frame of reference, it would be traveling backwards in time relative to another frame, and causality would be violated, where c is the speed of light, Ref 18. See the picture above. This is only the assumption event. The object is traveling from A to D. We have two observers, one observer named X moving with the object and the other one named Y staying at D. On arrival at D, the observer X opened the door of the craft and get handshake with Y. Observer X must get the absolute local time at D without denying. Observer Y says to X that he saw nothing observation of the craft or object coming at all before X coming. X arrival there is all of a sudden like a ghost. Yes, that is because X and the craft travel faster than light. So, X arrives earlier than the light to send the observation of X travel. Then they both watch what happens next. For object traveling from A to D with the speed faster than light but less than 2 times the light speed, starting since D arrival of X at D, both observers will watch the observation of backwards travel of the object from D towards A, with the speed faster than the real movement of the object from A towards D. And for object traveling from A to D with the speed more than 2 times the light speed, starting since D arrival of X at D, Both observers will watch the observation of backward travel of the object from D towards A, with the speed slower than the real movement of the object from A towards D. So, it would be traveling backwards in time means an observation of the object traveling backwards. Like we can see our action on the mirror, we expect causality wouldn't be violated. Cosmos objects dynamics. Most galaxies are present in mighty superclusters of galaxies that are traveling in cosmos. The dynamics of galaxies in cosmos are caused by 5 main reasons. 1. Pushing force of dark matter to cause superclusters of galaxies to continue to spread in cosmos. 2. Gravity of universes core that attracts mighty superclusters of galaxies toward universes core. 3. Gravity of neighboring superclusters of galaxies to cause them to combine. 4. Galaxies dynamics in mighty superclusters of galaxies. 5. Random cosmos events like difference density between cosmos area, influence of dynamics of superclusters of galaxies to the environment, and other events at cosmos. Pushing force of dark matter is responsible for cosmos objects to scatter throughout cosmos. This is the main reason of most cosmos object redshift. Nevertheless, except the gravity of neighboring superclusters of galaxies at our local space, all these reasons tend to also give redshift. Redshift and blueshift describe the change in the frequency of light wave depending on whether an object is nearing or receding us. When an object is receding us, the light from the object is indicating redshift, and when an object is nearing us, the light from the object is indicating blueshift. So, cloud and rain model has no problem with most cosmos objects' redshift are connected to Hubble's law. Against the statement that it isn't objects that are traveling, it is space which are expanding. Please note that space expanding is still only an assumption or interpretation to answer why the observation of most cosmos object redshift and connected to Hubble's law with Big Bang theory. Every of us realized that until this time, that assumption could be right, could be wrong. It isn't a final conclusion yet. Not to mention this assumption or interpretation isn't compatible with equality pattern fact. It means other possibility besides space expanding concept could also be right. Just a simple note. As long as it is still assumption, never close the door toward other possibilities. The one which giving less mysteries should to consider more. Cloud and rain model has a note that a redshifted object that having z value much bigger than 1.0 could either mean that the object nearing or receding, or object moving with the speed much faster than light. Whether the object nearing or receding the observer will always indicate redshift. That is because on the above situation, the light of the object that arrives first to the observer is always the light that comes from the nearer position of the moving object, regardless it is starting or end position of the moving object. Observation to objects moving much faster than light, or z much bigger than 1.0. See the picture above. This is just a simplification to objects travel faster than light that we observed from our galaxy post-MW. See the picture above. Then take a point x where the angle of x1, x, MW is 90 degree. Distance x, x1 equal 3 times x, MW, and x, q equal x, x1. Assume this is just a simplification, an object with constant speed flitting from q toward n with speed 3 times the light speed, while MW just stationary over there. This is a simulation and simplification of the expecting event where MW also moving, while an object flits faster than the light speed with acceleration from q toward n. Since that object leaving q to x, we see nothing at all yet. That object flits with the speed 3 times of the light speed. The light from the object at pos x will arrive earliest at MW, and that is when the object arrives at pos x1. Then, at that time, we will watch the instant appearing of an object like to blast at pos x. Afterwards, that object will divide, becoming two objects that move toward opposite directions. One object will flit towards n, while the other one will flit towards q. At the moment we observe that object on pos x, the light that comes from that object at pos q just arrives at q2. The observation of the movement from x to q is unreal. It is just like a shadow. The real movement is that object travels from q towards x, which we will never get this data if we use redshift observation just like for the redshift z less than 1.0. But the redshift we get with this unreal movement has been highly amplified. The z value for the unreal movement from pos x to pos q is significantly so much higher than the real movement from pos x to pos x1. And this situation is so much to correlate with the identification of dark energy. The misinterpretation of the redshift reading for objects traveling much faster than light as described above could be the amplifier of the identification of dark energy for the era after around the year 2000. The trap is coming from the grasp that nothing can travel faster than light. Actually, only ordinary matter cannot travel faster than light.